Okay, so let's go ahead and get started by creating a new model. We'll make sure that the ICM model template has been selected, and then I'll enter in the model name, and I'll just call this Training Platform, for instance. Now, I'm going to also make sure that the Start Trim will Connect is turned off, so that way you don't have that dialog box popping up, and we're going to use single user mode here. We'll go ahead and press the Create button, and a new model will be created, and we want this created in our C Tekla Structures models folder, not on the server. We're going to actually only copy to the server whenever we need to make a backup copy when the job is done, or periodically for progress updates. But the model itself is going to be stored in the cloud because we're going to use the Tekla model sharing. And so we want the model to actually be running specifically on our computer in this C Tekla Structures models folder, so that way it'll be faster whenever we're doing our production. Now once the model is created, I can open up the 3D view here. And before I do anything, I'm actually going to do the model sharing. So every project, whether or not you're the only detailer on the project, or if there's going to be other people participating on the project with you, will be stored in model sharing. So that way anybody can join this at any time in case you're sick or you're out of the office. Now, if we come up here to the Tekla menu, we will then go to sharing. And then what we can do is we can say start sharing. This will then open up the model sharing service. And basically what we're going to do is we're going to add the email addresses here for all the people in the company, all the detailers that we're going to invite. Now here in the description, sometimes I'll just say initial model. So that way I can keep track that this is the initial creation of the model sharing out to the cloud. But what I'm going to do is I'm going to go in here to open model folder. And I've got basically this user email list. And I'm just going to grab that, and it's semicolon delimited. So I'll just copy those. Then I'll go back here into Tekla, and then I can just paste that right there. So there you can see those email addresses, and then I can choose editor, owner, viewer, or project viewer. In most cases here for all the detailers, you're going to set this to editor, or potentially you can make everybody owners, which means that they have full admin rights to manage the job, to invite other users and things like that. So you might switch everybody to owner, press add. And then you don't want to really send the email notification to everybody because, really there's no need to do that. If they need to join the project because they're working on it, then they know that they can easily join that because every model is going to be shared with everybody. So then from there, I'd press start, and then it's going to actually upload that model out to the cloud, and then it'll make that available. I'm actually going to do that here, and then you guys will actually be able to join this model. This is under my model sharing, but you'll still be able to join it even though you have your own separate model sharing service, and the models can be created under your platform service here. But there you can see that the initial share is being written out, and here I've invited those people, and it can actually tell me when people have joined. But I'll just go ahead and say close, then go back into Tekla Structures. And when I've done that and successfully shared, at the upper left-hand corner, there's going to be these read-in cloud icons and then write-out cloud icons. So when I come in here and start making changes in the model, I can just go in and I'll start doing the grid here, for instance. So 0 spacebar 20 foot, then I'll do 0 spacebar 15 foot for the Y direction, and then I'll just do 0 and 0 here and modify. Then I'll click on the background so that way the view is selected, right click and say fit work area. And now I started to make some changes, and then I'll save the model. Now at any time here, I can come up to the top left after I made those changes, and I can write out the changes. So when I press that button, it'll prompt me and say, what have I done? I'll just say modified the grid. And then I'll just go ahead and say save. Now, when I do that, a small individual packet of just the changes that I've done since the original upload of the model share are going to be written out. So each time you do changes, it's not going to rewrite the entire model out. It's just going to do the changes since the last time that you wrote out the model. And that way it's a lot easier to absorb changes as the job progresses. So just as a recap here, as you produce and do things during the day, you're going to save your model. And that's only going to save the copy of the model on your local hard drive, which I can see up here at the top in my C Tekla Structures Models Training Platform model. But if I want to save this out to the cloud so that way all other users can read in those changes, then I need to come up here, periodically throughout the day, and definitely by the end of the day, and do a write out so that way my model is written out to the cloud and all my changes are written out to the cloud. Now, before you can write out, if there's any changes that somebody else has actually already written out, you actually have to read those changes in first. So there's going to be like a little notification badge, like there might be a 1, 2, 3, 4, and that just basically shows you all the packets that other users have written out that you need to read in first before you can do the write out here as shown. So in fact, if you tried to do the write out and there were packets that were already out in the cloud that you have to read in first, Tekla will force you to read it in or give you a notification that you have to do that before you can write out. So just remember that hitting save does not automatically write to the cloud. That just stores the model on your local hard drive. You actually have to come up here and do the write out in order for those changes to go to the cloud. Okay, so now what if we have to go ahead and do this job up at 100 foot zero? I'm going to double click on the grid and I'm going to change the Z elevation here to 100 foot, and then I'll do spacebar for the top of my platform at 100 foot, 110 foot. Okay, so I have 100 apostrophe spacebar 110 foot, and then down here I'll call this basically slab, or I can call it like, base elevation or whatever, spacebar, and this will be the labels, and I can just say T platform or something like that. Okay, so what I'll do is I'll then press modify, and you'll notice that the grid disappears. What's actually happening is it's moving up 100 foot, and because it's moving up 100 feet, the grid is not intersecting the view plane down here at 0, 0, which is where this default 3D view is created. So what I got to do is I got to click on the background, so I see this golden border around the view. That signifies that the view has been selected. I'll then right click and choose move, linear, and then I can come in here in the Z elevation and type in 100 feet. Okay, so if I don't put the feet or the apostrophe there, then it's going to think it's inches. So I need to make sure I do 100 feet. I'll then press the move button, and here it's prompting me, are you sure you want to move it? I'll say yes, and then I'll close this dialog box, right click and interrupt. And now I actually have to click in the view again, so that way it's selected, then right click and say fit work area. And then now what that does is it moves the work area box, which is what you're seeing here, this kind of green box around the grid. It actually moves that work area up to where the grid is, and now the view plane is up at 100 foot, and that's why we're seeing this grid. Because the grid elevations here are up at 100 and 110 foot, and that grid elevation here, the Z elevations, are actually intersecting the view plane, which is now up at 100 foot. That's why we can actually see the grid again. And I know that I'm 100 feet up in the model because I can see that the green global origin cube here is down here at 0, 0, and it will always be at 0, 0 in the model. So that's how I can easily tell that, yes, my grid appears to be 100 feet up above, and I'm good to go to work in a 100-foot elevation. Now the next step is to go ahead and generate some views. I can come over here to the View tab, and if I want to manually create views based on my grid information that I want, then often what I'll do is I'll go up here to the View Properties button, I'll open that up, and then there's these View Properties dialog box that I can start with. If I go to the drop down, I'll load up, or I'll select Plan View and press the Load button. Okay, then here it fills in the dialog box. You have to make sure you press Load, then Plan at Elevation. I'll actually just go ahead and say Plan at Slab, or I could just say Floor Plan here. That might be one way to do this. And then I'll just press Apply, and there's the view depth up and down, so I'm only seeing things down at that 100-foot level. So I'll press Apply, then I'll go to New View, Basic View, and Basic View is used for creating plan views. So I'll go ahead and do that. Then here we can see that the coordinate that I want this view to be created at is going to be 100 foot. Now I've got these settings applied here for the name and the view depth, and then I've got the Z elevation that I want, and I'll press the Create button. And look at that, there's now a new view here called Floor Plan. Okay, now I'm going to go ahead and close that. Then the next thing I'm going to do is I'm just going to go ahead and say Top of Platform, or I'll just say Platform Plan. Okay, then I'll just go ahead and press Apply, and then I'll change this to 110 foot. And then I'll press the Create button. So again, I needed to press Apply so these settings get stored for the next new view that I'm going to create. I'll change my Z elevation, press Create, and there we go. Now we have that top of steel for the platform plan. Now, I'm going to go ahead and close this down, and then I'll close down this new view that I created. And what I'll do is I'll go and create elevation views. To do that, I can go ahead and say Elevation View, press Load, and then it fills in some default settings for me to start with. Now I'm going to go ahead and say Elevation View on grid line A. I'll press Apply, and then I can go to New View using 2 points, and I can press the 2 points here that I want to create my elevation view. Now, a lot of people think that they need to go the full length of the grid. You can do that, but you don't need to. Grid views, or these elevation views, are actually infinite. So really, you just need to pick 2 points, and if you go left to right, you'll see the green arrows denote the direction in which the view will be created. If we go right to left, you'll see that it reverses that and looks from the inside of the building out. So one thing that's nice about creating your own elevation views manually is that you can create them anywhere you need to, and it doesn't have to be dependent on the grid. And if you want to have the elevation views looking from the outside of the platform or the structure or the inside, you have full control over doing that when you create the views manually. So I'm just going to go ahead and click those 2 points. And now I have a new elevation view, and you're going to see that in my grid labels, there's the top platform, which is my 110 elevation, and then my slab, which is at 100 foot elevation. All right, so once I'm all done with that, I can close those down, and I'm going to close these dialog boxes, and I'm going to go up here to my view list. Now, what I'm going to do is I'm actually going to select these views, and I'm going to show you a different way to create the views. So I'm going to select these, and one important thing is that if I'm going to delete these views, look at what's selected. Is the 3D view is selected in the background. I'm actually going to show you what happens when you mess this up. And even though it doesn't look like it's selected here, it's actually selected in the model. So if I hit delete right now, it's actually going to delete the 3D view as well. Oh, I actually got lucky. It used to actually delete that 3D view. It did not here, which is really good, even though it was selected. Sometimes that actually gets deleted. And so I wanted you to see that if you need to create that again, you would just go to New View, Basic View, go to View Properties, and you would load up 3D view, apply, okay, set that 100 foot elevation and create, and then it would recreate the 3D view if you lost it, just in case that ever happens to you. Okay, so let's go ahead and create the views based on the grid. Okay, so to automatically create the views based on the grid, we can select the grid, right click, and choose Create View along grid lines. When we do this, a dialog box will appear, and it has these default prefixes here for the labels of the plan views as well as the elevation views. Now, what I can do is, because I'm not really specifying the elevation, like the Z elevations in my grid names, like here it says slab and top of platform, I'm just going to go ahead and take the EL dot out, but I'm going to leave a little space bar at the end so it has a space between the actual grid label name and then the prefix for the view names on it. Now, I'll just press create, and there it automatically reads the grid lines and generates all of my plan and my elevation views based on the grid. Now, one thing I want you to understand, though, is that when it does create the views, just so you can see this, when it does the elevation views, the views are here vertically in the Y direction are always cut from right to left. Okay, so be aware of that. It's more making these views from a structural erection plan type of scenario. And if it's doing the X direction or the left to right, it's always going to be looking from the bottom towards the top. That's how these views get created. And you'll see that if I open up elevation on grid line 1, it's going to show grid line A on the left and grid line B on the right. So see how A is on the left, B is on the right, which means that I'm cutting this view here from the right towards the left. Okay, now one other neat thing is that if you can have up to 9 views open in Tekla at any time, I tend to like to have like a 3D view as well as have my 2D view open at the same time. And to easily tile those, I just come up here to Window, Tile Vertically. That way I can work and see both views at the same time. Now what I'm going to do is I'm going to go ahead and save the model. And then maybe I want to go ahead and write these changes out to the cloud. So I'll come up here to my model sharing icons and I'll press the write out. And I'll just go ahead and say created views. I'll go ahead and save. And then now that will then be published out. Now, one thing that's important to understand is that when you create your views, one thing that might have happened is they might not by default be set to be shared with model sharing. So let me show you what I mean. Here on this elevation on grid line 1, if I double click on it, it actually shows not shared. And that's not what I want. So if I created these views and I did the write out right now, nobody would see those unless I select shared as the option and press modify. Now I'm going to go ahead and do that on these other views as well. So I'm just going to go ahead and select on each one of these, modify, and then I'll just go one by one through each of these, double click on the background, switch it to shared and modify, do this one, and then I'll do a couple more here, modify, and then one more, shared, modify. And now once I've set all of those, I can just close these out. And then what I'll do is I'll then write out again, and I'll just say write out, and I'll say created views or adjusted grid views, something like that. And then I'll just say save. Now you don't have to use those notes, but that's just really handy so you can kind of keep track of the different changes or progress that's happened since you've last written out. All right, once that's all done, I'll go ahead and save and we'll start modeling in our columns. Okay, so now I'm going to go ahead and model in my columns. I'm going to go to the Steel tab for that, and I'm going to double click on the column icon. Now, in the model template, we spent a lot of time putting together good save settings. So as a standard, I did plus ICM for our company initials. And here you can see that all of those settings that are specific to our standards are now grouped together. And by putting the plus in the front of the name, they're now at the top of the list. Now I'm going to go ahead and start out with some W columns. Now be aware that when I start out with these settings, the bottom of the column is set to 0 and the top is at 3 foot, but we're working on a 100-foot zero job. So I'm going to do 100 foot here, and then I'll type in 110 foot for the top of the column. And you know what I'll do just for this job? I'm going to go ahead and press save. So that way those settings are now stored for a 100-foot job. And if I put in new columns and load these settings, then I'm going to have that as a starting point. Let's actually go to the HSS here, and I'll do the same thing. I'm going to set this to be 110 foot for my top of platform, and I'll do 100 foot for the bottom. And then now I'll just come up here and press save. Now what I'll do is I'll just go ahead and start by putting in my first column. And I'm going to close down the elevation view. And I typically put my columns in 3D view because it's easier to see. Sometimes if you do it in plan view and you're zoomed out too far, you won't actually see your columns easily. So it's best to do it in the 3D view. Now, I'm going to start over here, and I'm going to go ahead and pick this location, and that'll put in my column. Now, I'm going to interrupt right away because the first thing I want you to see is that at the very beginning of the job, usually even before I do any sticks, after I get the grids and the views in, and even sometimes before I even do that, I will come up here and I'll go to Project Properties, and I fill in the job number. I'll just put in a job number example here of 25001 as an example, and I'll just call this Training Platform, etc., and whatever you have on your title blocks. Now I'll modify that. Now the other thing that I come and do is at the very beginning of the job is I go to the settings, and then I go to options here, and I check whether or not I need to change the project north. And so if I go to orientation marks, you'll see right here there's this project north, and this will impact the mark face direction for columns, and particularly on the shop drawings to show the shop and the field which way a column should be orientated when they're erecting it out there. Now right now it's set at 90 degrees, which that means the north is lined up with positive Y. And here it says that it is the angle that is counterclockwise from global X. So if global X is going to the right and I put in 90 degrees, then that means positive Y. Now, I'm going to go ahead and leave that alone. That's exactly what I want. So I'll just set that. I just wanted you to see that that's where you would go to set the project north. And then the next thing is that I need to properly set the column rotations if I want to consistently have the mark face to be, for instance, to the west and to the north. Now, right now, I have this set to this rotation to front for this 4x4 by quarter. What that means is the front face of this column is actually lined up with the negative x-axis of the current work plane. So the front face is over here and the top face is here. And you can actually see this length measurement here when you're in a true plan view. The length measurement here when you have the column selected will actually point diagonally towards the top face, which is here, facing in the positive y, and the front face, which is here in the negative x. Now, if I switch this to top and press modify, then now the top face is here, and then the front face is here towards the south, and the top face is to the west. Now, to note, whenever you're doing columns and you want to put the mark face direction on your shop drawings, and you want to do it consistently, then basically what's important to understand is that the mark face in Tekla is always the top flange of the part. So currently, if I set this to top, and basically what that means is that the top surface of that column is lined up with the negative x-axis. That is the mark face. So if I actually made a shop drawing of this right now, the mark face for this column would be mark face west, because the top flange of that column is lined up with the negative x, and which is basically the west direction in the model, because north is positive y. So that's something important to important to make sure that you understand. And you want to do it as consistently as possible, so that way the field doesn't get confused and the shop doesn't get confused in marking things in lots of different directions. Now, let's go ahead and go over to some wide flange columns. So I'm going to again load settings, and here's the power of using save settings. A lot of users will come in here and just change the profile, and what do they forget? They forget to change like the material grade, the class, and other prefixing information, and then they make errors and mistakes. So the whole idea of spending the time of doing good setup and good save properties is now I'm going to load up my wide flange column settings, and I've got the correct material grade, the prefixing, and everything I want, and I even saved away the right top and bottom of steels here for me to get started. Now, I'm going to do my first column here. I'm just going to put both of them actually in, and you can see that they're rotated the same way. Now, if I put these in and I select each one of these columns, you're going to see that length, basically kind of dimension line there, is pointing to the top and the front. Now, if I look at this, the rotation is front, and front and back is always going to be the web, and the top and the bottom is always going to be the flanges on a wide flange part. Now, what this is basically showing me is that the mark face, which the top flange is here, is going to be north, and the front face will be west, because I have the front face lined up with the negative x-axis. Okay, and now what if I want to rotate this horizontally? To do that, I'll go ahead and click on this column, and we'll switch this to top, and I'll press modify. So now the mark face is over here on the west, and the column front face will be drawn from the south. So that's kind of the direction in which the column will be drawn, and this will have a mark face of west, and this one here will have a mark face of north. So depending on what you want to set as your standard for the erector, you can make sure that you consistently input in your wide flange columns in a direction that is going to make that clear, so all the shop drawings are the same. Okay, so now what we'll do is we'll go ahead and do Control P on our keyboard to switch to 3D, and we'll double click on our column command. And I don't need to load any different settings here because all the prefix and everything's right. I'm just going to type in a different profile for my column, and then I'll just go ahead and pick the intersection of grid line A and 1, and there is our column. To escape out of the command, because I'm not doing any more columns, I'll right click and interrupt, and then I'll save my model. And again, if I want to, you don't need to do it this often, but if I want to write these changes out to the cloud, I can go ahead and write out, and I can just say added columns. Okay, so let's go ahead and model in the platform beams. I'll go to my view menu at the top of Tekla, view list, and here I'll go ahead and open up my plan at top of platform. So when I do that, it now opens up that view, and if I go to window menu at the upper right, tile vertically, I can see the 3D view and my 2D view at the same time. Now if I do Control P over in this view, you'll notice that the grid is shown at the top of the columns, whereas over here in the 3D view, the grid is shown at the bottom of the columns. The reason that this happens is because the grid itself is intersecting the view plane at 110 foot, because that's where this view is created. The 3D view, its view plane is down at 100 foot, and that's where the grid intersects that particular view plane. That's why you see the grid at different elevations or different levels between the two different views. Now, I'm going to do Control P and just go back here, and when you're in a 2D plane view and you model in steel, then that steel will be locked or input specifically on that view plane. When you model in 3D, so for instance here, if I load up the beam properties, if I come in here, you can see that I can snap actually on any plane in 3D space. But if I'm in a 2D view, or the 2D perspective of it, then when I come in here and I put in a beam, it is only going to lock in at that view plane elevation. So if I do Control P, you can see that it is there at the 110 foot elevation. But while I'm rotated in 3D, you'll notice that I can snap anywhere in space. So that's something important to make sure you understand. The view plane elevation and location will then lock when you're in 2D where your snaps and everything are going to pick to. Now I've got this beam in here, and I'm going to double click, and I want this actually to be a W12 by 26. So I'll just go ahead and modify that. And then what I can do is I can either activate the beam command again and model that up here. And if I do that, it'll actually remember the last modification that I did here in the properties. Or I can just select on this beam, and then I can right click and say copy. Now I can actually start here in the 3D view, and then I can even finish in the 2D view, and you'll see that it copies across. So basically it's interactive views or perspectives into the same 3D model, and you can bounce and input between different views if you ever need to. Now I'm just going to come in here and go back into the beam properties, and we will do a slightly different size here. Let's do W10 by 12. These are pretty small depth framing members, but I'm just going to go ahead and go bottom up here on this one. And the reason why I'm modeling bottom to up and left to right on the two horizontal beams is because by default, I kind of want Tekla to make the mark end or the left end of the members towards the left and then towards the bottom. And so when you actually see me click on the beams, you'll see that the first point picked is always going to be this yellow point on beams, and the second point is going to be the magenta. Now, it doesn't guarantee that when Tekla does the numbering or the piece marking that the piece mark will always be towards the yellow end, but in general, Tekla will typically do that. Now, I did set up the numbering settings here underneath drawings and reports, numbering settings. You'll see here that I actually turned beam orientation off. So there could be beams that are modeled right to left or left to right, bottom, top down, in all sorts of directions, or even some beams that are still modeled left to right, but Tekla will actually look from left to right or right to left along the member. And because I have beam orientation off, it might actually combine pieces and have some of the pieces with the piece mark on the left and other pieces that have the same piece mark with the piece mark towards the right. So that's something important to make sure you understand. Now we do have column orientation checked. So the column orientation here, like for this column versus this column, is going to impact the piece marks. So even if the connections and the geometry of the materials were identical, if I have these rotated and orientated differently, Tekla is going to give them different piece marks. And the reason why I did that is because we had chosen and decided that we're going to show the mark face direction on our columns. So that's why we have that set here. Now in general, I don't really typically ever need to touch these settings. I've got these saved away as standard, and usually in most cases, unless I have to do some post fabrication revisions, I will never ever come in here and touch these settings. I just leave it at standard, apply an OK, and I'm good to go. And then when I'm ready to run numbering, I will do so. Okay, so let's go ahead and do some infill beams. And I'm actually not going to divide this equally, but if you did have an equal spacing here, I will show you how to do that if it's not nice even numbers. First, I would go to the Edit tab, and over here towards the right, there is a divide line points, or this on-line command here. So if I do that, I can tell it that I want 3 points, or actually, sorry, 2 points, so that way I can have 3 equal spaces here. When I type in 2 and press apply, Tekla is expecting me to pick the first point, and then the second point, and then it basically gives me 2 points here and 3 spaces equally divided between the first and the second point that I picked. And that's how you can do nice even spacing beams here. Now I'm going to go ahead and interrupt, and I'm going to do Control Z to undo that because I don't want to do that in this particular case. I actually want to show you instead by going to the Steel menu, double clicking on the beam command, and here I'll type in W8 by 10. And I'm going to use a W8 by 10, and I'm actually going to do Control left click here at the lower left hand corner. Now let me show you another thing in Tekla to watch out for when you're doing framing input. The snaps are getting a little bit better where it actually shows you in black text like where you're at, and you can see by the size of the snap whether you're on the right type of snap or not. But look at this, you'll see that it's snapping to nearest and edges of material. And for us old school Tekla users, this is a bit dangerous. And so I tend to tell people to come down here when they're doing the main stick framing input to turn off the snap to geometry lines and points. It's the second button down here on the snap toolbar. Now when I do that, the other thing I sometimes do is sometimes I'll actually turn the nearest points off. So that way there's no risk of me like snapping away from the true center lines of the steel. And the other nice thing about that is it allows me to be zoomed out a bit more, and I don't have to zoom in as much to make sure I'm snapping to the right point. Now I'm going to come down here and I'm going to say Control on my keyboard and left click. That's one way to do this. Another way is I can right click and say Define Temporary Snap Reference Point. When I do this and I click down here at grid line A1, that is not actually seen as the first point of my beam. You can see down here it still says pick the start point of my beam. So that Define Temporary Snap Reference Point is just a reference point that I'm going to offset from. Now if I hover my mouse to the right, this defines a direction, and I'm just going, I didn't click over here, I'm just hovering my mouse to the right, and I'm going to type in 4 foot, and you'll see that the numeric location dialog box appears. Press OK, and now that's the start point of my beam. You see that Tekla says pick the end point of the beam. So I'll then just go up here, and there's my beam. Now, this time I'm going to use the Control key. So if I hold down Control on my keyboard and I click here at the intersection of grid line 2A, I'll click that but while holding down Control, hover my mouse to the left, I'll type in 4 feet, and then I'll go perpendicular here, and that will put in that beam. Now, if the perpendicular snap doesn't turn on, you can control which snaps are turned on and off down here. So I'll just make sure that's on for the future, and I'll have my perpendicular there. And maybe I'm ready to turn my nearest. And then maybe even if my snap geometry lines and points, if I want to go to edges material, then I can turn that on if I want to. Now, I'm going to leave those off just for now because I'm going to still go ahead and do some channels next. Okay, so next what we'll do is we'll put in some channels here just to change up the different types of profiles we're using. I'll double click on the beam command. I'll then go here to my save settings. Again, this is the beautiful thing about having good save settings and a good naming convention. Now, instead of me having to sit here and change the material grade and all that manually, I'm just going to come in here and I'm going to load up my ICM channel settings as a nice starting point. Here I've got a default size, but I'm going to change this to basically C8 by 11.5. Okay, so that's my starting point here. Now, what I'm going to do for this one is I'm going to come down 2'6" from the top of this beam. So I'm going to do Control, left click, hover my mouse down and type in 2'6" and press OK. And there's the start point of my beam. I'll then go perpendicular here to the right, and there is my channel. Now I'm going to right click and interrupt for a second because I want you to see that the orientation is not the way that I want it to be. I want it to be actually towed towards the outside because this is going to be framing and opening. Now, you can try to rotate these around, and you could actually do it with rotations, but then the beam would be upside down. So I don't really want to do that. Now, if I come over here, we actually have our ICM group, which has all of our tools. So this is something that I usually do with customers is I've set up this set of tools specific to the types of connections and things that you commonly use. Now, there's a nice little swap handles tool here. So if we select on the member, double click, that will actually reverse the yellow and the magenta point, and you'll see here that now the channel is towed the opposite direction. Now here I can see that I want the input points to be the back of the channel. So I'll just double click back on that channel. It'll bring me back to the properties. And we can see that the material is going to the left on plane or on the X and Y plane. And I'm just going to switch that to right and press modify. And you'll see that the material is now going that direction. Now, the next thing I'm going to do is I'm going to model in the other channel, but I do want the channel to be towed downward on that one. So I am going to model that left to right. All right, so I'll go back to my beam command here, and I'll just do Control left click, and then I'll hover down and I'll do 3 foot. I'll press OK. I'll go perpendicular, right click, interrupt. I'll select on my channel here, and there we go. It's directly there on the back face, and it is towed the correct direction. So everything looks really good here for what I'm looking for and what I want. I'll just go ahead and save the model, and then I'll go ahead and write out my changes. Added beams, save, and it'll go ahead and write that out. Now, sometimes on projects, if I need to do a mill order run or do early purchasing of the material from a service center or warehouse, and I want to get that material locked in as soon as possible, then what I can do is I can actually just run a material list on the job. So to do this, I'll go to Drawings and Reports, and I'll go to the Reports button. Here, I'm going to scroll down until I find the 350 material list. So I can either select a just text file version of this or HTML or PDF. And if we just do the basic text file, one thing that sometimes I'll do is I'll change the XSR to TXT as the output. And then I'll just say create from all, or I can window around the specific sticks of steel that I want. And I can say create from selected. And there it generates that report. And it organizes that basically by profile. And then it gives a summary of all of the length and the weight for that specific profile, which can help you in providing the needed materials for purchasing. So I'll just go ahead and close that down. And when I close the report dialog box, go to the Tekla menu here and go to Open Model folder. You're going to see that this is inside of the reports folder. And because I put that TXT extension, now you can double click on that and it opens up nicely with Notepad. So there you go. That shows you how to quickly generate an early, basically advanced bill or material list for early purchasing. All right, the next phase is probably to get the anchor bolt plan out or to do the base plate connections. And so I'm going to close down the platform, and I usually do this in 3D as well, but sometimes what I'll do is so I don't see the top of the platform and I just focus on the bottom of the columns, I'll close down the 3D view, I'll go to my views here, go to view list, and I'll go to my top of slab or that base of columns plan view. So I'll just go ahead and open that up, and then we'll maximize that there. And if I go to 3D, now I'm just seeing the columns and I'm not seeing all the platform steel up above. Now what I'll do is I'll just come over here and I'll go to my applications and components panel on the right hand side of Tekla. And it looked like you guys were using 1042 as the common settings or the component that you wanted to use. And here we did save away some standard settings, which kind of has the anchor bolts and everything kind of set the way that you want it in projection, set the kind of the way that you want it, how your engineers work. So I'll just say apply and OK, and then we'll just pick our column, and we'll pick that bottom of base plate point there, or the bottom of the column. And I'm just going to go ahead and put that in and see what that looks like. So it looks like you've got the grout and everything there. And the way that you've set this is so that way the grout will actually go up above the picking point. So that's important to understand, because some people will actually model their columns in at bottom of base plate point for the reference point. So that way when they make their anchor bolt plan, that'll show the bottom of base plate elevation that way. But this is perfectly fine too. But it was good for me to see how you did this. So if I double click on this, and I go over here to the anchor rods tab, I can see that you have the grout above the picking point with the slope. So that's basically what that's set at. Now, what I would do from here is, knowing for this column size, I would potentially change the spreads out and adjust that to whatever the engineer has specified. But what I'll do is I'll just come over here and I'll put in the same settings here on this W10. And if I need to manipulate the spacing for a smaller column size, I easily can. But I'm just going to go ahead and put these in. And then I'll even put it over here on this column. And this is probably where I'm going to do a little bit of work, because this column is so small. So I'll just double click on this particular one here, and I'll go ahead and change the spread. So if I have a 4-inch column, do 1.5 clear on each side, that's going to give me a 7-inch spread. So maybe here on the, let's see, okay, looking at this, a little bit different than the other components. So it doesn't look like you actually have the ability to control bolts. Yes, you do. Sorry, it's just over here on this tab. Okay, so what's neat about this is that if you actually look at the cone direction, you can see that the cone direction is pointing that way, and this is actually a cone right here. And so that'll actually tell you, it looks like you've got edge distances, and you've specified kind of like the center to center here. But let's actually just fill this in. So I'll do 2. And then I think I said 7 inches and 7 inches. I'll select on my component here and press modify. And now that's tightening up. But back here on the parts tab, you had the actual size filled in. So watch, if I take this out and press modify, you'll see that it centers that, but then the spread is basically, going off of the bolts tab. So if I had something that was asymmetrical, how would I know which direction the bolts or the numbers I'm impacting goes? Well, if you look at this is a wide flange. This is actually showing the web. And this is a tube in the model, so it's not easy for me to see that this is the rotation of the column by the blue that it's shown here. So then I use that cone. So see the little tip of the cone in the picture? There's the tip of the cone there. If I typed in 9, then I know that it's going to follow that direction of that cone. So I'll select that and modify it, and there, sure enough, it elongates in the same direction parallel with the cone. And then you can also offset the base plate as required if you ever need to do that. Now I'm going to go ahead and change that back to 7. We'll modify, and then sometimes what I'll do is, for this job specific requirement, I'll just say HSS 4x4 and then save that away. And now I can use that if I had other HSS 4x4s on this particular job. Now, whenever you do a save as on any of the settings dialog boxes in Tekla, if you like these settings and you actually want to use this, because 4x4s are pretty common columns on multiple jobs that you do, then you can always come up here to the model folder and then go to the attribute subfolder, sort by date modified here at the top, and you'll see that there is that new attribute setting. Now you can then copy that to your updates folder or into your model template, so that way that can be used for future jobs. Now, if I were going to make anchor bolt drawings and anchor bolt details, then what I would do is I would probably come up here to drawings reports, and I would perform numbering at this early stage of the job so I could get piece marks for my anchor bolts. So I go to perform numbering, and I would do number modified objects. The reason why I choose number modified objects is because any new or modified steel in the model will then get piece marks. And so I'll go ahead and do that. And then now it'll assign piece marks to those anchor rods. So if I go ahead and change my selection down here at the bottom of Tekla to select objects and components, I can click on my anchor rod, and I can right click and say inquire part or inquire assembly. And you can see here that these are all joined together. The orange represents the main part or the main shaft of the assembly, and the yellow parts are sub-material parts that have been added to that. And I can see that here in the parts list displayed here in this report. Now you can see here that this is AB1 for the assembly mark. So see how it's got the AB1, and that's been assigned. And if I had different anchor bolts, then there would be AB1, AB2, AB3, etc. And so again, if I double click on this, you can see that there's the prefix for the anchor bolts, and the part prefix here would be used if I actually had that as not the main part, but because this is the main part, then that rod gets the AB mark there. Now I could then make shop drawings of that, and a simple way to do that would be to just click on this anchor bolt, and then I could come up here to create fabrication drawing. And when I do that, it's going to bring up a dialog box. And because I have a part selected, it's choosing W for workshop drawing, or also A for assembly drawing. Now I don't want the workshop drawing. One way to quickly get rid of the single parts is to just come down here to visibility, check the eyeball next to parts, and then only the A drawing will be shown. Now then I can come in here and find bill of material anchor. So I'm going to do one piece or one assembly per assembly drawing. So I'm going to use the BOM settings that are designed here for one piece per sheet. So I'll select on that and press create. And then when I do that, it'll create a new drawing here. And if I go to Drawings Reports menu at the top of Tekla, Document Manager, and then I go here to my Assembly Drawings category on the left, we can see that there is that new anchor bolt drawing. If I double click and open that up, we will then be inside of the drawing editor, and here you can see that it's got some very basic settings to kind of get us started with our overall dimension, and then we've got these thread dimensions that are shown. Now sometimes what I'll do is I'll just take these and let's see if there's some thread settings in here. Doesn't look like there's anything with thread starting, so I'll just come down here to the tag and I'll just say thread and press modify, and there we go. Now it says threaded there. So once you clean that up and move marks around and things that you need, and if you need a single part view, you can sometimes just click on that plate and say right click, create single part views, and then there's that dimension there. So that way it's very easy for that to be sent over to a subcontractor that specializes in anchor bolts, or if your shop does that, then you can just easily deploy that out to the shop and release that out. All right, so we'll close that down, and I'll just go ahead and say mark ready for issuing. The reason why I do this when I close this is so that way I can keep track of the drawings that I've not only created, but I can also keep track of what I've cleaned up and scrubbed, and that's ready for checking or ready for release. And you'll see that there's that checkbox here. And I can uncheck that or check that here directly in the document manager as well. All right, so now that I've got that anchor bolt plan, drawing done, the next thing would be to actually make the anchor bolt plan. So I'm going to do Control P here because I'm going to actually use this as my base. And then what I can do is I can go ahead and create that anchor bolt plan. Okay, so let's go ahead and create the anchor bolt plan. I'll go up to Drawings and Reports, Create GA Drawing, which stands for General Arrangement Drawing, which I use for erection drawings. I'll select my Planet slab, go to the Drawing Properties button, and here in the drop-down list at the top, there are a few different types. I'm not going to cover all of them. I'll actually use the anchor plan with details, where Tekla automatically tries to create the blown up details and the callouts for like detail A, B, C, etc. I'll go ahead and say load. And then what I can do is I can actually, before the drawing gets created, go to view, and I can go to the anchor bolt plan tab. And this is where you can actually control the scale of the enlarged views that it does on the columns, as well as the scale of the detail views. So I'll just go ahead and set that to 12, so that way those look nice and to a good size that I can show for my blow up views. I'll press apply and OK, so that way those settings are stored, and then I'll check the open drawing checkbox and create. Now this will then create that anchor bolt plan and open that up, and then what I can do if needed is I can just kind of move these views to wherever I need to, and so that way they line up nicely. And then I can just move and resize my plan as needed. Now when I move this, it should grab these blown up views. So you'll see that there's these inner view borders, and those are the blow up views that it does to enlarge this. And when you see all these white lines that are behind there, that's basically the original like anchor bolt base plate and the column base plate, the column and the anchor bolts. And it's basically showing those as white because it hides those out, and then it creates these additional sized views on top of that. So that's basically what's going on there. That's why you see these kind of different views, and then there's that exterior, and that's what that white stuff is inside of there. Now you can move and change this as needed, and let's see if we can actually modify this and make it a little bit bigger. So I'll do 36, and when we do that, it scales the blown up views appropriately, so that all looks pretty good. All right, so once we've got that set up there, we can go ahead and close that and mark it ready for issuing. And we now have the anchor bolt assembly drawing as well as the anchor bolt plan all good to go. Now, if I go back to the document manager, you'll see that I'm on assembly drawings, but if I go back to all drawings, there's my type G or erection drawing and my type A assembly drawing for me to go ahead and release. Now, I can then go ahead and click on these two drawings, and we'll go to revision button here at the lower left, or right click and say revision. Now, if I'm releasing these for approval or for field use, I can come in here and say for approval, load that up, and I can put in my initials here, and then I can say like what is today's date. And so I'll just come in here, and if I want to clear this to today's date, I can easily backspace that, and then now it'll bring me to exactly today's date, and I can say for approval. So I'll say create. Now let's say that I want to do for field use or for fabrication. I'll just go ahead and do 0, and then I'll leave today's date, and I'll just say for field use or for construction, whichever you want to use. And then I'll just go ahead and say create, and now 2 actual revisions have been created on those drawings. Now I just want you to see that if I open up the anchorable plan, we should be able to see here at the lower right, there's your company information and there's that Rev 0. And so now we have essentially that there and ready to release for field use. I'll go ahead and close this down. And then from there, we can select the 2 drawings. We can right click and choose print. And then from here, if we leave this at auto, it should automatically detect the paper, but let's just click on this and see how it looks. And we'll go to the next drawing. Looks pretty good. I don't want this to be in color, so I'll just say black and white, previous. Everything looks pretty good there. I'll open the folder when finished. It's going to print to the subfolder of the plot files. I'll press print. And then when it's done making those individual files, there we go. There's my assembly drawing, and then there's my AB1 erection drawing, and I can go ahead and submit those out for approval or for field use. Okay, so next let's go ahead and apply some connections. Let's go ahead and go to our view list here underneath the view menu. When I do that, I'll then open up the plan at top of platform. And now I can go ahead and do Control P, so that way I can basically see the connections in 3D as I'm applying them. Now you'll see here that the steel is transparent in the model in this view. And so one thing that's important is whenever you're in transparent mode, you cannot click on the piece in the middle of it. You actually have to click near the edge of it. The reason is because you can see through steel here. And so Tekla doesn't know, are you trying to select that far side beam or are you trying to select this beam? That's why you can't select in the middle of it, and you have to click near the edge. Now, to avoid that, I can do Control 4, which will then turn the steel solid. If I do Control 2 on my keyboard, then it'll turn it transparent. All right, let's do Control 4 just for the moment to make it a little bit easier to apply connections. And then what I'll do is I'll just go over here to my Applications and Components panel on the right. There's my ICM group for your particular components that you commonly use. And let's go ahead and start maybe with some clip angle connections. So I'm going to go ahead and use clip angle 141 as a starting point. And if I double click on this, I saved away some standards when we did your model template that basically has your default clip angle size, a lot of the part prefixes and material grades that you want, and then it has the bolt information and things that you wanted here by default as a starting point, and then we're just going to go ahead and fill those in and use that. Now I'm just going to go ahead and say apply and OK here, and then I'll just go ahead and pick my column, and then that's my primary or my supporting member, and then I'll pick my secondary. I'll pick my column, and then I'll pick my secondary, and here you can see that it puts in those clips. Now, when I rotate around, you'll notice that this beam here, which this is a little bit larger, the W12 by 26, and this is a W10 by 12. Notice that the bolts are automatically coming in here. Now, where is it reading that bolt information or the number of bolts from? If I double click on the cone, so that way it opens up the connection dialog box and go to the bolts tab, notice here that I did not fill in the bolt information. So I didn't enter in this information here. And so that information is coming from the member size and what is called the joints.def file. If I open up the model folder here, and then we scroll down until we find the joints.def file, we can right click and say open with notepad. When I open that up for clip angle connections or joints, it's basically looking at the actual depth of the member, and anything that is greater than, for instance, this 6.5 but less than the 11.5 is going to get 3/4 inch diameter bolts, and it's going to get 2. That's why the W8s and the W10s are going to get 2, but anything that's greater than 11.5, which will be W12s, but less than this 15.6875, which is going to cover W12s and W14s, is going to get 3 bolts. Now, the number of rows of bolts and the diameter for shear plates or shear tabs is controlled here underneath shear joints. Now, right now I've got this set up to fill up the beams with the maximum rows of bolts, which is probably what your engineers have set on their connection tables. Now, there's no design or engineering here. This is just kind of a standards file that you can set up, so that way you don't have to manually or individually set those number of bolts on each different connection type within the connection dialog box. Now, the next thing I'm going to do is I'm going to select on one of these cones, and I'm going to right click and say create view, default views of component. That gives me 4 perspective views. Now, if you had one of your views maximized before you did that, the last view that it creates is maximized. So you come up here to the upper right and press the restore down here right above the window drop down menu, and that'll show you the 4 views that it created. Now, when I look at this, essentially what I'm trying to look at is maybe the edge distances here. So I have objects and components down here at the bottom, and I typically call these the Christmas tree icons. They're basically just the green cones though. So select objects and components lets me pick on the individual entities inside of the connection, whereas selecting components will actually highlight the entire joint and all of the objects created by it. So I'm going to do objects and components. And there is this neat little measure command. If I go to edit and measure and do bolt spacing, here it says select on the bolt, and then I can pick on the part that I want the information on. And sure enough, it shows me the spacing and the edge distance there. Now this is showing me 1.25 inches. And let's say that our engineers want us to put in 1.5 inches edge distance on all this. So if I then hold down Control or select on the first cone, then hold down Control and select on the second one. And if you actually double click when you're selecting the second one, that'll open up that one's dialog box, but also maintain the selection. So let me show that again. If I click on this one, hold down Control, and then double click on this one, it maintains and adds this to the selection, but opens up that dialog box. Now, I'm going to uncheck all the checkboxes here, because maybe there's some settings in here that I don't want to modify that are different between these two connections, and all I care about is the bolts. A lot of people don't understand that these checkboxes are just the affect and modify checkboxes. So what that means is if you turn off all the checkboxes, only the fields that you actually touch or check are going to be impacted when you press the modify button. That's a great way for selecting lots of different connections that are fairly similar but don't have exactly the same settings, and you only want to modify a couple of particular values or settings there. So I'm going to go ahead and type in 1.5 inches, and so I'll do 1.5 inches on the top and the bottom, and you'll notice that only those 2 fields are checked. I'll press modify, and there it has increased the edge distance on those clips. Now, if I like that as a standard, I'm going to go ahead and save this as standard up here at the upper right-hand corner. And I'll press OK and close that. Now, the reason why I wanted to press OK here versus say cancel is that if I press apply and OK, when I do either one of these two, apply will leave the dialog box open, but it'll remember those settings going forward. If I press OK, then it's going to remember those settings that I just did in there for the next new connections that I'm going to apply. So I'm going to go ahead and close this down, and then I can apply those connections on the other beam to columns. Now, one thing I just want to recap is that if I open up the model folder, I can go back to attributes, sort by date modified here, so that way the arrow is going down, and I look here and there is standard J141. J means joint and 141 is the connection number we were just using. And anytime you save any settings away as standard, all lowercase, just for consistency's sake, but anytime you save anything as standard and you put that in your model template or here in this model, whenever this model gets opened, standard is what is loaded by default in that dialog box. So standard means default settings. If you like these now adjusted standard settings and you want to use this on other jobs, then you'll copy this over into your model template attributes folder. Okay, so now I'm going to go ahead and save, and I'll just go ahead and apply the rest of the connections here into the wide flange columns using clip angles. Okay, so I went through and I applied all those other connections at the other wide flange columns, but now I'm going to go ahead and do a shear tab here at this HSS column. To do that, I'm going to scroll down until I find shear plate simple 146. Now I'm just going to go ahead and use standard here. So even without double clicking and opening the dialog box and loading any settings, whatever I had saved away as standard in my model template is what's going to be loaded by default. You'll see 3/8 shear tab here, all the part prefixes that I want, all the bolt diameter and everything that I want here, the edge distances. And the key here is that I've actually left the number of bolts and the distance down to the first hole from the top of the beam empty. That will tell Tekla to read from the joints.def file for the number of bolts based on the beam depth, and it will actually look at the K distance or the radius and this vertical edge distance to try to adjust that distance down to the first hole if the standard 3 inches down to the first hole will not fit the K and that edge distance. That's why I leave that empty there. So I'm just going to go ahead and say OK, and I will pick my column, pick my beam, pick my column, pick my beam, and there we go. Now, in this particular case, it looks like it worked out where the setbacks on this had cut this out. But if I had two really wide beams here, then what I might need to do is come in to actually open up the connection dialog box. And if you go over here to the notch tab, you can actually control the top cuts on a beam. So if I actually came in here and typed in 1 and just said modify, for instance, you can actually control how this is cut out. So let's actually do an override here where I specify this, and then you have the top and the bottom controls there. And so if I select on that and I type in 1 inch on each side, all right, and then I'll just switch a couple of these options here so I can control exactly what I want. I'll select on the cone again here and press modify. See, what else do I need to fill in? I've got this dimension, and I think I need to enter in that length. So let's say modify. There we go. So there's that cope. Now it's on the wrong side, right? So then I can come in here and I can say, hey, I don't want it on that side. I actually want it on the other side. So I just come up here and I will do the other side option, press modify, and now I can see that there's that corner there. If I needed to cut these because the flanges of the beams were wider than the other one. So if you ever need to do any manual overrides, you can do that. And if I need to come over here to control the side of the shear tab, like which side of the column that's on, I can always come in here and just change this drop down, press modify, and then it will adjust the side that the shear tab is on. So you can do individual controls beyond your standard settings as required. Now I'm just going to undo that back because we don't need to do any of those changes. I'll just redraw, and it looks like everything is all set there. Now, one thing I do need to be careful of is just kind of if I have a clip angle on one side and a shear tab on the other, I do need to make sure that this is easy to get in there. So I probably want this shear tab actually on this one on the other side. So I'll just modify there, and now that shear tab is there. Now I'm going to undo, and maybe I only want this one setting because I don't want that cope that I just kind of did in there. So I'll uncheck the checkboxes. It's again another good example of just this particular field that I want modified. Hit modify, and now only that value that's checked will be impacted. All right, so go ahead and redraw that there, and now we have all of our beam to column connections all set. Okay, so let's go ahead and finish up by doing our beam to beam connections. So I'll go ahead and activate my shear tabs here, and I'll do the girder and then the secondary beam. I'll go ahead and do this basically W8 by 10 and then the channel. And then I'll come over here and pretty quickly get that done. And there we go. Now that's all connected. Now, once I get those in, one little trick that kind of need to watch out for when you have W8s or channel 8s is the distance down to the first hole. So I'm going to check this out and see how well this came out. If I select on this first cone here, I'm going to right click and say create view, default views of components. Gives me my 4 basic views. Now, whenever you leave basically the distance down to the first hole empty, so watch this, I'm going to change my selection to components. That way I can just easily touch anything on the component and open up the dialog box. If I go over here to the bolts tab, I left the distance down to the first hole empty. So if I actually measure this from the center of the bolt to the top, you'll see that it did 2 9/16. So what it's doing here is it's actually looking at the cope size, which the cope size is based on the larger of the Ks of either the supporting or the supported member. So how can I see the radius there? Tekla actually doesn't show the radiuses to kind of speed up the display or the rendering of the graphics. But if you click on the beam here and you hold down Shift, right click and say show with exact lines, look at what it does. It shows the K radius there on that wide flange member. And that gives you a clear representation of why it made the cope size this depth based on the K radius of the primary member or the deeper member. Now, when I did that, it saw that, hey, I cannot do 3 inches down to the first hole. And that's why I did the 2 9/16 here. Because if I did do 3 inches down to the first hole, then what it would have done is the bottom of this shear tab would have run into the K radius of the W8 because the W8 is not tall enough to handle 3 inches down the first hole and 3 inch spacing. So when you left this empty, Tekla figures that out. Now maybe I don't like that 2 9/16. So what I would rather have is 2.5 just to keep the number nice and clear. So what I would do here is I would do 2.5 and then I would select on that component, press modify, and now it's just adjusting it ever so slightly. Now, it is going a little bit above the cope there, so that edge distance is a little bit small. That might not be something that I want, and I can also always go to the notch tab here, and I can kind of forcibly decrease that cope size a little bit if I want to. So here, if I had a little bit of clearance and I just wanted to do 1/2 inch for that distance there, you'll see that now it just decreases that cope, and there's still plenty of clearance and room there. So that's something I could maybe do. Now, if I want to use this, I could say W8. Right? And usually what I do is I make this maybe my like save settings, and then I'll go to the general tab just so that way I can kind of keep track of which connection settings I'm using. press modify, save that, and now I can see that that's the settings that I want to use on all the other connections. Now, what I'm going to do is I'm going to close these 4 views down, and since I'm probably going to have this issue on all these other connections, I'm just going to go ahead and select on all of these other connections here that are going between those W8s. Now, if I double click on the last one here and I load up W8 in my drop-down settings, I can press modify, and then since all those connections are pretty similar framing, now those all have that 2.5 inches down to the first hole, and I can redraw. And then as needed, to have my shear tabs stay out of that opening if I need that full clear opening space, I can again come back to these individual connections here, go to the plates, and usually what I do if I'm just modifying 1 or 2 properties is I uncheck the checkboxes like I've been showing before, hit modify, so only that particular field is being impacted. I'll press modify here, and now the shear tab goes to the opposite side for those 2 connections. So there we go. That gives you a very clear and quick kind of guide on how to apply the connections. And the beauty about this is I saved away my standard starting point settings with all of the nuances and a lot of the defaults that I have on my connection design sketches. That way I don't have to manually fill that information over and over again. I saved that away as standard, put that in my model template, and now I have a great starting point to just focus on applying my connections in the model.